Hi there, kids. Today looks like it's going to be a challenging lesson. Actually, it's a pretty straightforward lesson, no big deal at all. The big question today is what is the derivative of e to the x? And right now you're asking yourself what the heck is e to the x? You had a very poor trig teacher last year who didn't teach you anything. Sorry about that. But let's just kind of remind you what that is. If you look at the graph of y is equal to e to the x, e is simply a number, say 2.71. And if you look at an exponential function, it has this type of a graph. It travels through 0, 1, because anything to the 0 power is 1. Do you ever wonder why that is? Why anything to the 0 power is 1? For example, x to the fifth over x to the fifth, those are the same things, so you get 1, and yet if you subtract them, you get x to the 0. So anything to the 0 is 1. So that's the graph you get, e to the x. It's an exponential function. E is just a base of 2.71. And really the cool thing about it is this, is that the derivative of the exponential function is itself. The derivative of e to the x is e to the x. Suppose you had a different function that was exponential, say b to the x. But the derivative of b to the x is b to the x times the natural log of b. So we just add on that little extra piece there. But for the most part, when you're dealing with calculus type situations and you do with exponential functions, e to the x is one that comes up very often. So just consider e to be a number like you would pi or any other number. So let's find the derivative of the following. We have f of x equal to x cubed times e to the x. Notice in this situation that you are going to be required to use the product rule. F prime g plus g prime f. Therefore, the derivative is equal to, if we take the derivative of x cubed, we get 3x squared times e to the x plus the derivative of e to the x is e to the x times f, which is x cubed. Now, I would choose to factor this. I'd take out a x squared e to the x. When you take out an x squared e to the x, you're left with 3 plus x. So I would accept either or on the test. I just want you to know that in the answer keys, you will often see it listed this way. Next example. This is a composition function. We have e to the u, and we have 4x squared. So you can see that if you dump the 4x squared into u, you get e to the 4x squared. This will require the use of the chain rule. By now, you're excellent at the chain rule. E to the u is the outside function. The inside function is 4x squared. Derivative of 4x squared is 8x. And the derivative of e to the u is e to the u. Multiply the two together, and we get 8x e to the 4x squared. And that is f prime of x. So yeah, the derivative of e to the x is e to the x. It's a great, it's one of your favorite derivatives because you never have any problem remembering it. Let's go over some other examples. In this situation, you can tell you're going to use the quotient rule. Remember the quotient rule is f prime g minus g prime f divided by g squared. If you haven't already made a list of a bunch of different derivatives, whether that be the quotient rule, product rule, chain rule, but also the derivative sine, cosine, secant, so on and so forth, it would be really good of you to put together one page of notes regarding that. It would help you to be much more efficient with your work as they come up, instead of having to trek back through all of your notes. So I know that you're capable of doing that. Derivative. I start with the derivative of the top, e to the x, times the bottom, 2 minus x, minus the derivative of the bottom. The derivative of the bottom is negative 1. So it will be plus, because of the negative 1, times f, which is e to the x, all divided by the bottom squared. Now, I I am going to factor the top. F prime of x is equal to, if I factor out an e to the x, I'm left with 2 minus x. Then I have a plus 1 over 2 minus x quantity squared. Notice that the 2 minus x plus 1 becomes 3 minus x divided by 2 minus x quantity squared. Not too bad. So this is one that's going to take a little bit of time. You're going to need to show patience. I'm going to rewrite this a different way. A lot of times people struggle to see exactly what's happening with this derivative. This function can be written as e to the 3 sine of the root of x, that quantity cubed. So this cube is cubing the sine operation. And if I write it like that, you would be correct to say that I set it up as the chain rule. Here I write 3 times the sine of the root of x cubed. And it starts off nice and easy because the derivative of e to the u is e to the u. But the derivative of the next piece, that is going to require the chain rule again. Identifying the outside may be challenging to see. But if you consider that I'm taking this thing, cubing it, and multiplying by 3, hopefully you see that the outside is 3u cubed. That means that the inside is sine of the root of x. Once again, the first derivative is easy, 9u squared. Remember to substitute your sine of the root of x back in. The derivative of sine of root of x, let's require the chain rule one more time. I have sine of u, I have the root of x. The derivative of sine, as you know well, is cosine. The derivative of root of x, you've done that many times now, 1 over 2 roots of x. When you multiply the two together, I get cosine of the root of x over 2 roots of x. That is what goes here. 2 cosine of the root of x over 2, well, I'm sorry, no 2 on top, over 2 roots of x. Now multiply those, and you get what's going to go here. 9 sine squared of the root of x over 2 roots of x. And now finally multiply these two together, and we get 9e to the 3 sine cubed of the root of x times sine squared. Oh, sorry. Yep, sine squared of the root of x. Looks like I missed the cosine of the root of x right there. Cosine of the root of x. And that all sits over 2 roots of x. So, ugly derivative. But when you look at a problem like that, just ask yourself, what if you would have had to go back to this? The limit as h goes to 0 of f of x plus h minus f of x all over h. If you had to determine the derivative that way, well, you'd stare at it for days. You'd have no chance. And I wouldn't either. I wouldn't know what to do. But the use of the chain rule makes the derivative, well, it took about 5 minutes, but it wasn't too bad. Let's go to an easier problem. This will be our last one. This is going to require the use of the chain rule again. And the outside this time is u to the 1/2. The inside is 4 minus 4e. I'm sorry, 4 minus e to the 4x. The derivative of u to the 1/2 is 1 over 2 roots of u. You know that by now. But this derivative, the derivative of 4 is 0. And the derivative of negative e to the 4x, well, that requires the chain rule. Negative e to the u and 4x. The derivative of negative e to the u is negative e to the u. Derivative of 4x is 4. So that derivative is negative 4 e to the 4x. Multiply these two together, and you can see that the negative 4 and the 2 will make negative 2 when you multiply them together. E to the 4x in the numerator. And the denominator, the square root of u, which is 4 minus e to the 4x. And so the derivative, negative 2 e to the 4x divided by the root of 4 minus e to the 4x. So a couple problems, a little bit more challenging there at the end. But please, again, just note from the beginning, the derivative of e to the x is, in fact, e to the x. There's one piece that kind of got left out. That I want to show you. We're going to look at this problem, secant of e to the a pi x. As you set this up, you have f prime of x is equal to, and we'll set up the chain rule, secant of u, and the inside is e to the a pi x. A is going to be a constant. Anytime you see a function set up, x is defined as the variable. So whenever you look at x, that's the variable. Any other variable in that situation is determined to just be a constant. So a and pi would just be some constants. Derivative secant of u is secant of u tangent of u. Hopefully you remember that. And the derivative e to the a pi x, we set up this chain rule as well. We have e to the u and a pi x. The derivative of a pi x is a pi, and derivative of e to the u is e to the u. Multiply the two together, and we get a pi times e to the a pi x. Multiply these together, and we get a pi times e to the a pi x times the secant of e to the a pi x times tangent of e to the a pi x. And there you have it. So, good luck. Can't wait to see you back in class. A little bit shorter video. If you need help, don't be afraid to reach out or Google me. We'll check it out.